Welcome to this video on NetSim Network Emulator. A network simulator predicts the behavior of networks but cannot connect to real networks. NetSim Emulator enables users to connect NetSim Simulator to real hardware and interact with live applications. A network emulator can provide critical insights into application performance. It also assists networking teams to make informed decisions across the entire application lifecycle, help building what-if scenarios to choose between different network technologies and adjust application settings to optimize performance. Users can test the performance of real applications over virtual networks. If you are designing a new network or expanding an existing network and wish to know how your application would perform over the network, the tool to use would be NetSim Emulator. This tool will enable you to run your live application over an equivalent virtual network and see how the application is performing in real time. NetSim emulation comes with several path baking features. It can be scaled to hundreds of nodes in the network in between. It supports the entire list of protocols available in NetSim Simulator. It facilitates multi-tenancy, which means there can be multiple sources or destinations or client servers connected to the emulator. NetSim Emulator is trusted and deployed by hundreds of corporations, research institutions, and government agencies in military and space communications. For demonstration purposes, we have three systems in our lab setup, where one will be the source, another will be the destination, and in between the emulation server. The destination will receive real traffic, which undergoes network effects like delay, loss, error, etc., created virtually by NetSim Emulator. Our first objective will be to use ping to measure the round trip time for messages sent from the source to the destination and demonstrate how the link propagation delay of the virtual network will affect the real ping packets. Run ping on a continuous mode from the source to the destination without emulation, and we can see that the TTL value is less than 1 millisecond. Next, in NetSim emulation server system, we will create a simple network consisting of one router and two nodes as shown. In the properties of the two wired links, we set the uplink and downlink delay to 50,000 microseconds, which is 50 milliseconds. In the application type, we select emulation and select source and destination ID and change the source and destination IP address according to the IP addresses of the real source and destination PCs. Then we run the simulation. Now you will notice that the TTL value is on an average around 105 milliseconds. This is because the ping packets are being routed through the virtual network in NetSim containing two links of 50 millisecond delay each. Next, we will send streaming video from source to destination via NetSim and check the video quality. In the NetSim emulation server, we will use the same network scenario. In the source, we will set up VLC media player to stream video. After starting emulation in the emulation server, we will start streaming the video. In the destination PC, you can see the output streamed video. Now, when comparing the source video quality against the received video quality at the destination, one can observe a marked drop in the video quality. This is due to losses created in the links on account of bit error rate settings. Finally, we will check the performance of the connection between the wired nodes using the bandwidth performance tool iPerf. iPerf is a commonly used network testing tool that can create TCP and UDP data streams and measure the throughput of a network that is carrying them. After starting simulation in the emulation server, we will start iPerf at the source and transmit UDP data at a rate of 6 Mbps. In the destination PC, we will run iPerf and analyze the received data. We see that the received throughput is about 5.7 Mbps. Now in the emulation server, we will modify the uplink and downlink speeds in every link to 1 Mbps. So note that we are transmitting at a rate of 6 Mbps, but the links can support only 1 Mbps. So we start iPerf in the source and transmit UDP data at the same rate of 6 Mbps. In the destination PC, we run iPerf and analyze the received data. We see that the received rate is around 0.8 Mbps. This is due to the new uplink and downlink speeds of the links set in the virtual network. Thus, we are able to constrain the flow of real traffic, by reducing the bandwidth available in virtual links in NetSim.